Hi guys, Maths Guru here, Darren. Welcome to another video. If you are new to my channel, can you please subscribe if you're watching this on YouTube? Never going to be rich, never going to be famous, but it does mean that I know that you're watching. Greatly appreciate it if you could just click that little button. Turn off notifications if you don't want to hear from me, but please, please, please just click that button. Otherwise, mathsguru.com, as you can see above, has got all these videos free to sign up. It's got time codes and downloadable notes and so much more. Now, what are we doing? We're going to try and find the equation of a straight line if we know 2 points on the line. Now, I'm going to show you the textbook way of doing this, and then I'm going to show you my way of doing it, because there is a formula that makes life so much easier, in my view, if that's okay. Same principle, but just slightly different. Now, if you're following the General Maths course, this is building on the videos I've already recorded. Please go and have a look and watch them if you can. Alternatively, stop this video, download the notes, and then you can write all over them for the stuff that I maybe don't write down, or the stuff that you need. And if it doesn't make sense, leave me a comment. Say, you know, YouTube, what are you doing, dude? Otherwise, if you could leave a comment and say, actually, what I'm doing well, that would also be deeply grateful. All right, so we have met previously the idea that gradient, so this gradient of a straight line is given by rise divided by run. Why is that important to me? Well, because we're going to try and find the equation of a straight line, which is y equals mx plus c. Now, there is m for my gradient, and there is my intercept. But what if it's not easy to find the intercept? Is there another way of doing it mathematically if I've got other information on the graph? Well, yes, believe it or not, because that's what this video is about. Obviously, we're going to look at finding the gradient and the equation knowing 2 points. Ka-ching. That was one way of doing it. Ka-ching, let's cross that through for the moment. Yeah? There is another way that we said that m was equal to y2 minus y1 on x2 minus x1. Now again, if you don't know what I'm talking about, I've done a video on this. Stop it, go and watch that video. But generally speaking, we know that we have coordinates, 2, 1 for example, and 4, 10, which has an x value and a y value. So each of these are an x value and a y value. Now, a bit of a spoiler alert here. What do you notice is in my equation here, an x and a y. Oh, hold on a moment. We're going to use one of these coordinates in a moment to help us find my c value. Now you're going to go, what? What's he talking about? Again, it was a spoiler. Let's build up to it. All right, so the first thing is, because we've got 2 coordinate points and 2 x's, what we do is call one of them x1 and the other one x2, and that becomes y1 and that becomes y2. So if we go back to my equation, m is equal to, what was it? y2 minus y1 divided by x2 minus x1. I'm just going to substitute in my values. So the first one I'm going to do is the value of y2, which we know is 10. And I'm going to subtract from that the value of y1, which is 1. And then we're going to do x2, which is 4, minus x1, which is 2. And again, you can use your CAS calculator if you want. Hopefully you don't need to. But 10 divided by 10 minus 1 is 9. And 4 minus 2 is 2. And basically, we would leave our gradient like that. Now, lots of people go, well, wouldn't I write that as 4.5? Not really. Okay, we don't normally have y equals 4.5x plus 3. That seems a bit weird. And we definitely don't have y is equal to 4.5x plus 3. They don't necessarily make any sense. Now, you see, I've crossed these through. You download these notes in 3 weeks' time, and you're going to go, why did he cross those through? Should print them off. We tend to leave all gradients as either whole numbers where we can, or fractions. So there is a way of finding a gradient. But we also know from previous work that we could also draw a triangle, couldn't we? So we could have drawn my triangle between those 2 points, and I could have said, well, I'm going from 2 to 4, which is 2 squares across. I'm going from 1 high to 10 high, which is 9. So I know that m is equal to 9 on 2. Ka-ching. That's another way of finding my gradient. But what's really important is that we notice, as I say here, that a coordinate is a trick. It's nothing more than an x value and a y value that actually belongs in this relationship. And you're going to say, what is he talking about, relationships and x values? I know, I'm getting there, I promise. But using one of those coordinates, and I say one of them, is going to be really important to help me find the line. So let's complete the question. We already know that m here was equal to 9 on 2. Yes? Let's just check that. 2 across and 9 up. And we know my equation is y equals mx plus c. Now we are trying to find the value of c. So to be able to do that, the question must give me a y value, an m value, and an x value. Well, remember, we've already got the m value because we worked that out, didn't we? We worked it out as 9 on 2. Where on earth am I going to get this x value and y value from? Where would I'd get it from one of these coordinates. Which one you choose matters not a jot. Could not care less, but in this situation, I'm going to choose something with a 1 in it, because it makes life easier to multiply by 1. If I had a 0 in it, trust me, I'd be doing that as well. So remember, that is a coordinate of 2, 1. My x value is 2. My y value is 1. So where I see an x now, I'm going to put a 2. Where I see a y, I'm going to put a 1. And I'm going to put my plus c. Right, now you could do this on your calculator if you want. You could do solve, comma c, whatever. But I know that that divided by 2 and that times by 2 there cancel each other out. So that gives me 1 is equal to 9 plus c. I want the c on its own. I'm going to get rid of that plus 9 by subtracting 9 from both sides. That now disappears, leaving me with a c on its own, and 1 minus 9 is negative 8, and ka-ching, there we go. I've finished my question, yes? No. And sadly, again, the reason I don't like this way is people tend to get confused. They're like, well, I don't understand what's going on here because I'm finished. You haven't. All you've done there is find the value of c. You've now got to write the equation because it wants the equation. So you now have to go back and say that y is equal to m, which is 9 on 2, x, in this situation, minus 8. That there, believe it or not, is my answer. I've taken my m value, I've taken my c value, and I've substituted it back into y equals mx plus c. And to me, there seems like a lot of steps there. Let's do another example. I'm going to do it the way they did, and then I'm going to show you a different way of doing it, the way that I tend to do it. Right, so let's start. So first things first, we need to find m, which is my gradient. So we can do y2 minus y1 on x2 minus x1. The rest of the world is going, well, why would you? I'm just going to do, but anyway. So what have we got? We've got 1, 5, and we've got minus 1, 1. So let's call that x1, y1, x2, y2. So we're going to do y2, which is 1, minus y1, which is 5, negative numbers. And we're going to do x2, which is minus 1, minus x1, which is minus 1. All right, so 1 minus 5 is minus 4. Minus 1 is minus 2. The minus and the minus give me a plus, and 4 divided by 2 is 2. You given up already? This is nuts. Why would I do this? Let's just check the triangle method, because in this situation it might be simpler. How many squares have I gone? I've gone from minus 1 to 1, which is 2 squares. I've gone 1, 2, 3, 4 squares up. It's a positive gradient, so my gradient there is 4 divided by 2, which is 2. Ka-ching, thank you very much, moving on. Same. Now, what do we do now? Well, we know that y is equal to mx plus c. So we write my equation down and I'm substituting. Remember, we're trying to find the value of c. So they have to give us a y, an m, and an x. Well, we've got the m. We now know the m is 2. How do I find an x and a y value, I wonder? Oh, hold on a moment. I know I use a coordinate. Now, as far as I'm concerned, I would never in a billion years use a coordinate with a negative number. We already know that we don't like negative numbers. It confuses me. So actually, this situation, I'm going to use 1, 5. So let's write that down. 1, 5. There's my x value. There's my y value. So that's 5 is equal to 2 times 1 plus c. Well, 2 times 1 is 2. I want to get rid of a plus 2. I'm going to take away 2 from both sides. So c is equal to 3. End of question, yes? No. Because now I've got to substitute them back in again. So my final equation is y is equal to m, which is 2x, and then c was plus 3. Why was it plus 3? Because there's no negative sign in front of there. And so actually, that's my equation. Now, believe it or not, that's the end. If you're following the Cambridge textbooks here, that's your example done. In fact, I think I've done an extra example. Hopefully it's helped, but I'm going to do it a different way. There is a way of combining equations for gradient and straight line to give you just one equation. And this is the equation. It's basically y minus y1 equals m in brackets x minus x1. And you're going to turn and say, what? Now, basically, it's the same idea. Here is my value of m, and this y1 and x1 are a coordinate. It just makes life a little bit easier because I do it all in one stage and I don't have to worry about substituting. So watch what we're going to do. So this is the coordinate I'm going to choose. So that's 1, 5, and that's my y1 and my x1. The value of y here, you just leave it alone because that's going to stay in my equation. So I've got y minus y1, which we decided was 1, is equal to m. Well, actually, I'm going to use the same idea I did before. I'm going to draw a right angle triangle. That's 2 squares across, 4 squares up. M is equal to 4 divided by 2, which is 2. Ka-ching. So that's going to become 2, and in brackets. Now, because the x is just an x, it doesn't have a subscript number, I leave that as x. And my x1 is equal to, oh, hold on a moment. What was I doing here? Goodness gracious me, x1, y1. Let's try that one again. So that's actually 5, he says. All right, so the good news is this is live as you're ever going to get it, because again, what fascinates me there is every now and again you get things the wrong way around, don't you? And you go, nah, there's something not quite right, and luckily I caught up. So my x1 value is in fact 1. Now what do we do? When we have a set of brackets, multiply them out. Yeah, so we're going to do the 2 times the x and the 2 times the minus 1. So y minus 5, 2 times x is 2x, 2 times minus 1 is minus 2. What am I going to do now? Well, what do I want on its own? I want the y on its own, which means I need to get rid of a negative 5. I'm going to add 5 to both sides. So y becomes equal to 2x minus 2 plus 5. And so y becomes equal to 2x plus 3. Now, as a check to make sure we got this right, let's just check, did I get it right? 2x plus 3, ka-ching. Did it seem easier? To me, yes, because it did it all in one stage, so long as I remember that formula. 2x plus 3, also, can I check that I've got this correct? Did this cross through at plus 3? It absolutely did. Now again, to be able to do these questions, guys, you've got to be able to practice. So they say practices make perfect. If you've got a textbook or examples you can use for this, I'd smash them out. If you ever have any questions, let me know on maffsguru.com or let me know on YouTube. And if you can, if you're already still here, leave a message or a comment at the end of the video just to say what you enjoyed or what I could be doing better. All right, there's 2 more minutes. Thank you very much for watching. If you can stick around for those, would be greatly appreciated. Otherwise, subscribe, head over to Maffs Guru, and hopefully I'll see you in another video. Take care, guys. See you soon. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is maffsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.